Okay, so welcome back. So before we jump into examples, let's start by introducing one of the cases we might get when we're dealing with rational expressions. Okay, so the first case is that, well, before I get into that, the technique is always the same. So remember, it's always about factoring the denominator. So again, if the degree of the numerator is less than the degree of the denominator, then the next step is factoring the denominator. Okay, so that's the key, is we have to first find the factorization of the denominator. So in this case, what if all of the factors of the denominator are linear factors? Okay, so let's start with that first. Okay, and non-repeating, so they're all distinct. Okay, so that's the first case one. We have linear factors, they're all distinct. So we have no repeating linear factors. Okay, so in other words, no linear factors raised to a power. Okay, that's the other way of looking at it. Okay, so we have an expression like this where the degree of the top is less than the degree of the bottom. Then if the denominator q of x can be factored as factors of linear, right? a1x plus b1 times a2x plus b2, and all the way to anx plus bn, where each linear factor is distinct, then it is possible to find constants capital A1 through capital A sub n satisfying this equation. Okay, that's a fact. Okay, now we're not going to prove that here. The proof that such constants exist is beyond the scope of this class, but we are going to use this fact. Okay, and this is the first case. Okay, so our goal is to basically find those constants such that we can write them as a sum of each of the factors in the denominator. Now, how we do that is where the algebra comes in, and I'm going to show you how to do that in the next video. Okay, so and we're going to use an example to show you how to get these in the next example.